Okay, now let's look into some typical problems. When FC is defined, for example, calculate limit x squared plus 4 when x is approaching to 4. So it's really simple. We just plug in x equal to 4 into the function, which is 4 squared plus 4, which is 20. Okay. Example B, is this function well defined? Yes, the function is well defined. Okay, the function says when x is not equal to 2, it is x itself. For example, if it's a negative 1, 0, or 1, or 1.9, fx equals negative 1, 0, 1, or 1.9. But when x is equal to 2, fx equals 3. It is well defined. Okay? But the limit of fx when x is approaching 2 is 2. We cannot plug this number into the function to calculate fx because first, let's calculate lim fx, x approaching from the left hand. So when x is approaching to the 2 from the left hand, which means we are approaching to 2 from 1.9, 1.99, 1.99, and so on and so on. Therefore, fx value is 1.9, 1.99, and 1.999, and so on and so on. Therefore, the function value is approaching to 2. Okay, let's talk about approaching this function on the right hand of 2. When we say we are approaching the function from right hand, which means we are approaching from 2.1, 2.01, or 2.001, so on and so on, x equal. Therefore, the function value is approaching 2.1, 2.01, 2.001, so on and so on and so on. Therefore, when we are approaching from the right hand, the value of the function is approaching to 2. And when we are agreeing value, sorry, here is a bit mess. I'll rewrite this part. Lim fx, x approaching to 2, from the negative side equals lim fx, x approaching to 2 from the positive side. We can write it equals lim fx, x approaching to 2. Okay, which is 2. But from the function, when x is equal to 2, the function value is 3. Okay. So if if the function is defined and fc is defined, it does not guarantee that the limit of fx at c exists, or it's the same value as the function. Okay. Now we'll be looking at the function is not defined but can be defined after manipulation. Okay. Example 3. Find limit of this function when x is approaching to 2. Okay. When we look into when we are seeing the function, the limit function with denominator, the first thing that we need to remember is that always first step calculate the domain. Okay. So here the domain is x squared plus x minus 6 not equal to 0. Okay, x minus 3, x minus 2, x plus 3 not equal to 0. x not equal to 2 or minus 3. Okay, but the question asks us to find the value when x is approaching to 2. Okay, so let's write lim 2x squared minus 3x minus 2 over x squared plus x minus 6, x approaching to 2 equals lim x approaching to 2. 2x squared minus 3x minus 2 can be written as 2x minus 1, x minus 2. Then the denominator can be written as x minus 2, x plus 3. These are cancelled. Then we have lim x approaching to 2, 2x minus 1, x plus 3, which is we plug in x equal to 2. 2 times 2 minus 1, 2 plus 3, which is 3 over 5. Okay? So when FC is not defined, but we can manipulate, so we can still calculate it. Okay? This is an example from the previous final of the year 2013. Let's do it. Lim x approaching to 0 of the function 49 plus x minus 7. The domain is the denominator not equal to 0, therefore x not equal to 0. Okay? So for this part, this function, we time square root of 49 plus x plus 7 on the denominator and the numerator. Okay? Okay, so it becomes lim x approaching to 0 function square root, sorry, there's no more square root, 49 plus x minus 49 over x times square root of 49 plus x plus 7. Okay, then this is cancelled. 49 minus 49, we can write this as lim x approaching to 0, x times bracket square root of 49 plus x plus 7. Then we cancel the x, lim x approaching to 0, 1, 49 plus x plus 7. Then when x is approaching to 0, now we can plug x is approaching to 0 into the function, and this is 1 over square root of 49 plus 7, which is 7 plus 7, 1 over 14. Okay, so this is the answer.